I want to talk about some basic integration here. This is an indefinite integral. The reason we know it's indefinite is there are no limits. So no values here that we're going to plug in afterwards. That means it's indefinite integral, and we'll see how that actually changes our solution. We have a polynomial in here except for this square root, but basically it's a pretty straightforward equation. So how do we integrate this stuff? Remember, taking the integral is the exact opposite of taking the derivative. So when we have a polynomial for a derivative, let's take x cubed, for instance. When we take the derivative, we bring the exponent down, rewrite the term, and we write it to the new exponent, which is 1 less. So now integration is all about going backwards. So we've now got something like 3x squared. All we do for integration is we go up a term, up an exponent, I should say, up an exponent, and divide by that new exponent. In other words, if we want to integrate x to the 6 dx, we're going to go up an exponent, so up 1 from 6 is 7, and we're going to divide by that new exponent. This should make sense. You can always test your integration answers by taking the derivative of the answer. So the derivative of x to the 7 is 7x to the 6, and that 7 comes along down below. Those will cancel, and you get back to your x to the 6, which is right there. So let's take a look how we do it for all of these different terms. The first thing I'm going to do is get all of the terms in the form where they actually have an exponent. So this square root sort of stands out. We want to write that in terms of having an exponent instead of a root. So x to the 4 is fine, minus 5x to the 3 is fine, plus x to the 1/2. An exponent of 1/2 is the equivalent of taking the square root of a term. Minus 2 dx. A quick note on this dx, all that means is that we're differentiating with respect to x. So you could have a bunch of different variables within your integral, x, y, z, a, b, it doesn't matter. This part tells you which variable you are integrating with respect to. Okay, so let's solve this integral then. We said we go up a term, up an exponent, and divide by that new exponent. So x to the 4 goes to x to the 5, divided by 5. Minus, our constants come along, so that 5 is going to stay there. X to the 4 divided by 4. Plus, let's be careful here, 1/2 going up 1 becomes x to the 3 over 2. And then dividing by 3 over 2 is the same as multiplying by 2/3. Minus 2x, because this is technically like x to the 0. We don't write it, but that's like there's an x to the 0 there, so we're going up 1 and dividing by 1. The last part for definite integrals is we always want to add c. The reason for this piece, and be careful here, they like to dock marks when you don't write that for an indefinite integral. The reason we do that is because if we were to differentiate this whole answer, we would get back to this answer within the integral, which is great, that's what we want, but let's say there was a plus 5 on the end, okay? The derivative of that is 0, so we wouldn't even include it anyways. It could also be plus 500 or plus pi or plus any constant. When we take the derivative of it, it's going to go to 0. So we want to include the opportunity to have any constant there by adding plus c. That's your basic indefinite integral just using polynomials. Remember, take the exponent on the x, go up one exponent, and divide by that new exponent. Hopefully this is helpful. You can always send us more questions, info@arnoldtutoring.com. Thanks.